G'day everyone, welcome to Fully Charged Bro. Today we'll be discussing series and parallel AC circuits. It is important to firstly understand the difference between DC and AC circuits. DC stands for direct current, meaning the current only flows in one direction. AC stands for alternating current, indicating that the current flow alternates from backwards to forwards. Today we have Nikola Tesla, the founder of alternating current himself, coming in to lead us through this presentation. AC is produced by a spinning coil in a magnetic field, which means the current is consistently changing, both in magnitude and direction. The magnitude of the current with respect to time can be modelled by a sine wave, with the peaks representing the coil being perpendicular to the magnetic poles, and the zero values representing the coil being parallel. The amount of full rotations performed by the coil per second is known as the frequency, which is measured in Hertz. AC circuits often consist of three elements: resistors, capacitors, and inductors. Both capacitors and inductors store energy. Capacitors store potential energy in the form of an electric field between two parallel plates, whereas inductors store kinetic energy in a magnetic field around the coil. When a capacitor is fully charged, it acts as an open circuit since the potential energy storage is full. When an inductor is fully charged, it acts as a short circuit since the magnetic field has formed and the current can flow freely through. Both capacitors and inductors have a reactance in an AC circuit, which is the resistance offered to the current, and is dependent on the frequency. The formulas for the reactance across a capacitor and an inductor are demonstrated by Nikola here. This indicates that a larger frequency will increase the reactance of an inductor, but will decrease the reactance of a capacitor. These formulas give rise to the total impedance of the circuit, which is a measurement of resistance within a coiled winding. The formula consists of a real and imaginary element, with the real element being strictly resistance and the imaginary being the stored energy of the system. This additionally tells us that an AC circuit with only resistive elements will not consist of a phase shift. If the circuit consists of multiple capacitors or inductors, the total capacitance and inductance can be calculated by these formulas for series and these for parallel. Notice their inverse relationship due to their distinguishable way of storing charge. And that's all we've got time for today. Thank you, Mr. Tesla, for sparing some time, and thank you guys for watching. I hope this helped.